I've been selected to go to Malay College. And given a list of what is needed to go to Malay College. And went back, my father said, I don't have money. And that's when my uncle came around and said, no, he has to go. So my father gave ultimatum, you can go, but only for 1 term. If there is no scholarship, you have to come back. So I went to Malay College. Fortunately, after the first month, I received a federal minor scholarship, RM25 sebulan, RM25 a month. Then everything became history after that.
And because of my interest in the development of science, for not just for the university but for the country, the organization of research, when the science advisor's position was established in the Prime Minister's Department in 1982 or in 1983, as a matter of fact, my name cropped up as one of the possible candidates for that. I understand there were 8 names given to the Prime Minister's Department, and my name was picked up to be that person. So I became science advisor on the 1st July 1984.
And actually my first experiment, if it's of any interest to you, was with my brother. We decided to build a rocket to send a grasshopper in outer space. What we call outer space was just shooting up in the air and over the house. And we were just quite fascinated about the concept of energy and power and how things drive. And of course, my family wasn't rich. We put all our pocket money together and bought a few things, gunpowder and all that stuff. And we created our own little rocket, and we had no astronauts, so we caught a grasshopper and put it inside and shot it right over the house and came back on the other side. And the grasshopper was well and alive and ran off back to the bush. And it was quite exciting, at least for me. It was, I was only about 8 years old. That was a pretty exciting experiment.
I still remember way back then, while I was 14 years old, during one of the science, there is an experiment where you have to play a lot with the powders. You take the powders and then you burn it, and then it gives certain colors, red, blue, yellow, green, and so on. Instead of doing what my teacher said, I just tried to mix up 2 powders, 3 powders, and I mix up all the powders. And when I burn it, it's just like a spark of colors. So that is actually a basis of fireworks, and I think that is one of the moments that sparked the interest, which is actually all the colors basically fascinate me to do something related to science.
When I was in the primary school, when I learned something in the classroom, I would like to do the practical aspect of it. I remember when we were learning about when metal will expand when you heat it up. So I will go home and will use a small lamp or whatnot, and I would tie a copper wire and put a nail on it and try to have it touch a coconut, like a coconut shell. And it didn't work because of course the thing will not expand that far, but at least I learned that thing. And one that I like to do at that time also, I will make my own torchlight. So I will get a small light bulb, the one that people use for bicycle kind of thing. Then I will go and try to get some battery. Mostly those are already, been thrown away. So I would dry them, and then we'll take a piece of paper and wrap them and put a wire on it, and we'll use it because my house at that time is, the light will be off by 11 or so, 11 p.m. So I will use this small battery I like to read a lot of books.
The most important laboratory is up here, up in the skull, in the brain. And the apparatus and the sensors that you put into a laboratory are your own 5 senses. Your hands, your nose, your eyes, your mouth, your ears are senses that can analyze. So the concept of research must be carried in sophisticated laboratories. I cannot accept.
NDV is just a Newcastle disease virus. It's a virus that's been found to infect chickens, so it can kill a lot of chickens. So it is very, very important for the poultry industry. So this is NDV. You can, I mean, I've just got this rambutan here, but this is, you can portray it as an NDV where the virus has got various proteins, envelope proteins outside, which are epitopes, which will elicit the antibody response. And then inside here is the genome of the virus.
One is, of course, what is most well known is the pillar of conducting tests, catching athletes actually with performance-enhancing substances in their bodies, so that when they are sanctioned and punished, it will serve as a deterrent. The next pillar is the pillar of education. Education where we use all our endeavors to teach our athletes about the scourges of doping, not just the health effects, but also the fact that this is against the spirit of sport. And thirdly, we put in place mechanisms that will also now bring in other players in society, such that it is not just the sports bodies that are going to be involved, but we also look at criminal elements as well as the sources of these drugs. So it's a widening battle and it's an evolutionary battle. Steps are being taken to have an integrated approach between governments, sports bodies and the athletes themselves, so that together we can work towards at least, if not eliminating, keeping this scourge to a minimum.
Number one is we are among the first researchers in the world that produce competitive hollow fiber membrane which can be eventually used commercially to remove carbon dioxide from natural gas.
So my thoughts then turned to goats, and I then began to look at what do we know about goats, and I came to 4 important conclusions. Number one, the goat is a developing country animal. 97% of the world population are found in developing countries. Number two, the biodata, the base data on the animal was next to nothing. So little information. Number three, it had lots of tendencies toward helping poor people because it's found in very harsh, dry environments like north of Malaysia, northeast of Malaysia. And the fourth was the fact that it represented a huge challenge in terms of opportunities for R&D. So that started me off, and I can also happily tell you that the first ever energy requirement for maintenance were defined in Malaysia. Up till today, that's the first ever benchmark.
My main task initially was to revive or revitalize the rare earth industry within the country, and one way was to look at our resources. Where are the potential areas? Do we have a potential for rare earths? Of course, monazite and xanthine are the 2 main minerals, but they're tied up with the tin mining industry. So to revive the mineral rare earth industry means we also have to revive the tin mining industry.
Now, my passion is to help the poor, okay? So basically, why do I say this? Because I now realize there's no one to champion the poor. Many people don't know, don't care, okay? But the poor continue to be in poverty, continue to have no one wanting to do anything for them. So then I say, perhaps in the current concept of blue ocean strategy, to boldly go where no one has gone before. That is where I start to build up my research team to now move in this arena. And as a result of that, we have got, in my area, I wanted to have, like I said, something that can be done during my lifetime.
Science communication is a very important aspect of the whole science activities. But in the past, the scientists only communicate with scientists. Even that, the physicists communicate mainly with physicists through their journals, seminars, and chemists communicate with chemists. But nowadays, problems will require multidiscipline solutions. So not only that the physicists have to speak to chemists have to speak to biologists, they also had to speak across the pure science into the social science.
So for the young women of today, my advice is just go ahead with whatever you think you are best in. You just have to strive and don't think yourself as a woman. If you want to excel in your work, you must think as who you are.
As a scientist, no matter how great you are, no matter what kind of genius you are, if you do not know how to put across your idea, how to convince people about your idea, you may not get the funding. So presentation skill is something that I believe everybody needs. Right? Presentation skill, language skill. For example, when you talk to people, you must have eye contact with people. And these are all very lacking in our traditional kind of teaching.
There's still a lack of involvement of Malaysian scientists at the global level. Our scientists are still contented to be playing the role internally in the country.
Important thing is they must have the what you call passion to do all this, to actually pursue what they are supposed to pursue in science and also in technology, because both of this will be able to in fact support the economy later on. Without the fundamental understanding of science and technology, there will be no new economy, there will be no new what you call industry. So we have to rely on the young scientists to come up with new what you call that understanding of processes, of new materials.
Look at areas, and if you have the chance to do postgraduate research, try and spend some time working in the research labs of some top scientists in the world. Because we are global. Do not be short-sighted and just focus.
You must have passion whatever you do. And more important, you have a commitment. You have passion, you have a dream. And then you follow that dream, you follow that passion. Always remember that the eyes of the public are always on you. So underlying all that is integrity. Integrity, honesty. And my late father told me, and I wrote that in my autobiography, that even if it's 1 cent, if it's not yours, don't take it.
It's our hope to produce local Nobel Prize winners. But I think we can do that, provided we give proper encouragement. But we have to allow the scientists to develop whatever they want to do, rather than to tell them, okay, you have to do this type of research or that type of research. And lately I find that the government stress on application of research. I think that is killing some of their enthusiasm.